Welcome everybody. Welcome to part 2 of the PowerBox iServo series of videos. In this particular video, we are taking a closer look at programming these servos. So if you recall from my part 1 video, previous video, I did briefly mention that there are 3 options to programming these servos. So one of them is to use the mobile terminal, as we're going to show you today. Another option is to use the new PowerBox iServo terminal program. So that's a program that runs off your PC using the little PowerBox USB interface, and you connect it to the servo. And I'll show you some of the finer details of that particular software program in a later video. And the third option is to use a PowerBox core or atom transmitter. And that's on the proviso that the servo's using the P2 bus or telemetry option insofar as the connection to the radio system. So you need to basically be connected to the P2 bus to be able to program these servos from your transmitter. If you're using them, say, in a standard receiver PWM sort of configuration, so you're just using a normal receiver and you've plugged it into one of the standard PWM ports, you can't program the servo, or you can't access the servo remotely. And that's because, remember, the servos are really a telemetry device, so they send and receive data along the telemetry bus. So if they're not connected to that bus, you can't sort of talk to the servo. Let's take a closer look. So I've connected this servo to the mobile terminal, fairly straightforward if you've used the mobile terminal before. One thing I did find in playing with the servos is you've got to have a decent power supply powering the mobile terminal and the servo when you do this. So don't use a low current power supply. I was using it was a 5-cell AA inner loop pack. And I was having a little bit of trouble connecting to the servo. And sometimes when I was programming it, it was causing some weird errors. So I've gone to a 6-volt regulated setup, 2S LiPo would work as well, or a Life power pack straight into the mobile terminal, that'll be fine. But you need something with, half decent current capability. Okay, scroll across to P2 bus devices. So this option here allows the mobile terminal to talk to P2 bus devices. They don't sort of fall under the previous menu categories. So you'll find there's no servo option anywhere here, but it is a P2 bus device. So what this does basically, it mimics the protocol, or basically uses the same protocol as it's found on a receiver when you're using the P2 bus ports. And it talks to the servo, so we can send and receive data using exactly the same protocol. So let's take a look in here. So you click in there, and what it does, it goes straight to the servo. So you'll notice the first blue line there, it says HVC45_servo1A. That's the name given to this particular servo. We can actually change the name, and I'll show you how to do that in another video, because I don't think, from memory, you can't change it from the mobile terminal, but I'm pretty sure you can change it from the PC software program. And I can't recall if I can change it from the TX, but I'll take a look at that in the other videos. There's also a change address option. So you notice it says 5. So we're stuck on address 5 at the moment. So out of the box, when you purchase these servos, they'll come set to address 5 and with that default name. So don't confuse that address 5 with your servo channels in the transmitter. So if we connect this to the P2 bus, out of the box, these are programmed for setting up to respond to channel 1 as far as the servo is concerned. So like I said, if they're connected to the P2 bus, they'll operate as a servo using channel 1 on the transmitter. So this address 5 pertains to the P2 bus address range. So every telemetry device, remember it's a serial bus, so every device that's connected to the P2 bus, so that basically includes receivers, any telemetry sensors, plus these servos, all have to have a unique address. So you can actually change that from here. However, I don't recommend you do it from here unless you're keeping a manual track of what addresses are used by what devices. Because if you have two of the same devices, or 2 devices using the same address, there'll be a clash. Just be aware, like I said, out of the box, all these come set to channel 5. So if you're using a couple of these servos in your aircraft, before you fit them to the aircraft, you can change the address here. Or probably an easier option, and we'll cover this when I look at the transmitter programming, is to just select the next free address using the transmitter. Because when you use a transmitter, you can just push one button and the transmitter will automatically select the next free available address. So you don't have to think about it, basically. And that's the easiest option as far as I'm concerned. Okay, let's have a look at the programmable parameters. All you need to do is click on the name or press on the menu item. It goes in and recalls this. So this data is directly from the servo now. So what we're reading here is what the servo is telling us. So there's 2 pages of data. And one of the first options is just a mention of what firmware version the servo is running. So when I first received these servos, they were actually running firmware version 2.8, and I've upgraded them to 3.3. You can only upgrade the firmware via the PC version of the iServo terminal program using the USB interface. It's pretty easy to do. So just be aware of it. I think there was a minor bug in version 2.8, which has now been resolved. Let's have a look at some of these settings that we're probably more interested in. So the next option, you'll see a left hand and a right hand arrow, and it says saved. So what does all this mean? Well, what you'll find is when you change any of these settings, you then have to manually save it into the servo just simply by clicking. I found the left hand arrow doesn't really do anything. So for instance, just as a quick example, let's change this control channel here. If I push the left hand arrow, it doesn't seem to do anything. But if you hit the right hand arrow, it saves it. So that's saved to the servo. And while we're talking about this control channel, this is the actual channel that the servo will respond to if we're using it on a P2 bus sort of scenario. So remember, P2 bus, you connect one of these servos up to it, but you have to tell it what channel is it going to respond to as far as the transmitter is concerned. So if you're using a core, we can go all the way up to channel 26, and you'll notice there's an alpha character in brackets next to it. So don't forget, just about all the power boxes use alpha characters on their servo ports. So, if you've got port H, in effect, that's channel 8 as far as the transmitter is concerned. So this sets the actual channel that the servo will respond to. So if you have 2 servos and they're both set to say 1, if you move, say, your throttle stick and you've programmed throttle to operate channel 1 as far as the transmitter is concerned, both of those servos will respond to that throttle stick movement. So again, this is the actual transmitter channel that they will respond to, and it has nothing to do with the address we were talking about earlier for the P2 bus. So yeah, so some people get this control channel number confused with the P2 bus address. Okay, then we have a servo disengage option, a learn neutral position, a neutral position. I'll come back to these because I want to spend a little bit extra time on these. Some of the more common stuff that most of us are sort of familiar with when we're programming, say, S-bus servos or other programmable servos, you have the option of changing the direction of the servo. So if you want to, you can do it from your transmitter, of course, as well, but we can do it from here and program it into the servo. So if you want the servo to work in reverse sense, you can just change it here, go normal, reverse. Now, travel clockwise, travel counterclockwise. These units are in degrees, so just be aware of that. It's not percentage, it's in degrees. These basically set the amount of travel that will occur when you have 100% travel set on a PowerBox core or atom transmitter. Now, specifically say PowerBox core atom transmitter, because 100% on those radios is not the same as 100% on a, say, a Spectrum radio or a Futaba radio or whatever other radio. The PowerBox core and atom transmitters have an extended range. So 100% on a PowerBox core, for instance, is about the same as roughly about 82% or somewhere around there travel on a Futaba radio. And the core and atom can also go up to 200% travel, so just be aware of that. So again, 100% travel will equate to these figures. So this basically sets your travel adjustment for the servo. So if you set 100% plus or minus 100% in the radio, and then you operate a switch or move the stick, currently the servo will move either 60 degrees in the clockwise direction or 60 degrees in the counterclockwise direction. So again, it's basically calibrated for PowerBox core and atom users. So just be aware, if you set 60 degrees here and you're using, say, a Futaba radio, and you dial up 100% travel on a Futaba radio, you won't actually get 60 degrees. Now, there's also a speed and a speed limit option here. So you've got speed limit and speed. So at the moment it's deactivated. So if you want to activate it, you just press on the button to activate it. Now I can't show it to you in action because there's no transmitter connected to it. But later on in the other video, when I have the transmitter set up, we can see the effect of it. So all this is just a speed control for the servo. So for instance, if you want the servo to move at X amount of degrees per second, you can adjust the rate here. So you'll notice it's set to 1,800 degrees per second, which is a pretty crazy figure. I mean, the servo is not going to achieve that. I think that's just the maximum integer that you can actually type in. But of course, if you want to slow the servo down, we can do this. And you can fine tune it if you want to as well. So now I've set it to, say, 78 degrees per second. And from here we can either deactivate or activate it. So at the moment it's deactivated and that's active. And of course, don't forget that you need to save it to the servo. So you'd hit save and now it's saved. Go back there again. So that's just a speed control for the servo. If you want a slow servo, if you're using it for a particular application where you don't want the maximum speed, you can slow it down from here. And of course, you can use the same sort of thing in the transmitter. So PowerBox core and atom, you've got speed control from the transmitter as well. So I suppose if you use both together, you can make the servo really, really, really slow if you really wanted to, because you could set the maximum rate. I can't remember if it's 30 seconds or something like that in the transmitter. And also slow it down here. It'll make the servo fairly slow or very slow, crazy slow. Okay, we also have a torque parameter that we can adjust. So at the moment it's disabled. So it's a bit like the speed limit. If you want to activate it, you've got to make sure that's set to deactivate. It's like reverse logic, I suppose. It's not like a tick box. And we can set the amount of available torque that the servo will output. So, generally you'd want maximum torque, so you'd just leave it on deactivated. However, for, if you have some specific application, you can reduce the torque that the servo produces. And there is a limit. I think you can only go down to about 25% from memory. Yeah, 25 is the minimum torque value. So what will happen is basically it makes it into a weaker servo, I suppose, if you have a lower value. And there's also a torque delay. So I haven't actually tested this, but I assume that this parameter will come into play after about half a second. So we can change that to say, no, not sure 0 works, but you can go down to 0.1, 0.2, and obviously increment it as well. So probably find that the maximum torque available will be reduced after that time has elapsed. And the last option is a soft start. So that's really handy for aircraft that might have really large control surfaces. And as you know, these servos got a bit of torque and they're fairly quick. And you turn the model on and say your elevator's all the way down, it'll flip straight up really quickly. It's nice to have a soft start with a servo. When you first apply power, it'll go to its normal neutral position at a slower rate. So you can just turn it on that feature on and off from here. And you'll notice you can't adjust it from here. So it's set to, I think it's 100 degrees per second. But you can actually change it from the PC software, the iTerminal software for the servo. And again, I'll show you that. I'll cover that off when we cover that program in a later video. So most of these options are fairly self-explanatory, pretty easy to understand. Main thing to remember is you've got to hit the save button. So we're playing around with some options. If I disconnect the servo now, I won't actually save it until I hit this button. You'll notice it says save, so just remember to hit the save. Now, this is one of the handiest features of the servo, I reckon. So previously, PowerBox had a different type of servo that I think it was made by MKS. Don't quote me on it. But I don't know if you guys all remember the iServo 5. So I've got one of these servos. So this was a PowerBox servo, telemetry servo. One of the annoying things about those servos was you couldn't adjust the neutral position. Or you couldn't program it, I should say. You can obviously adjust it from the transmitter. But you couldn't save like a neutral offset in the servo itself. And I find that really handy when I use, say, my Futaba servos. I use the capability to program a neutral offset in the servo when I'm setting up my flight services. So I like to have like 0% sub-trim in the transmitter. It just makes it easier to remember a setting. So all my aircraft, I try and set them, make sure they all sort of read 0. It's just a habit, I get from good setup, I suppose. Doesn't really change the performance or anything like that, but it's instead of having say -6% travel as your neutral position, it's nice to be able to say, okay, I know it should be at 0, etc., etc. Now, with these new servos, we can actually offset the neutral position, so we can do the same thing as the old Futaba servos I was talking about. So that's really nice. That's fine. And we can just do that from here. So for instance, now this is in degrees. So if I put in, let's put in, say, 45 degrees. Now, close enough to 45, 46.3. So you'll notice the horn when it was at 0 sort of aligned vertically. Now it's about 46.3 degrees according to the mobile terminal. And again, we've got to hit save to save it. So now that's our new neutral position. So look, I don't have to explain to you why we use this offset for the neutral position, because most of you would know about it. But it's nice to be able to adjust it on this servo. But that's not the best feature. The next thing I'll show you is the best feature. Let's make this 0 again. So, I'm sure all of you guys are familiar with doing this, whether it's on your transmitter or in the servo when you're setting up your linkages. So let's go to exactly 0. There we go. And I'll just save it. So now that's our neutral position. Now, there's a couple of other options here, so that I'll just put them up the top. There we go. So we've got servo disengage and learn neutral position. Now, I just showed you how we can change the neutral position just using these left and right arrows. So we can go left and right, clockwise or anti-clockwise, no problem. Then we hit save, and that's our new neutral position. However, there's one other option we can use on these servos, which I really, really like. I reckon this is a real handy option, or can be a real handy option. Now, at the moment, the servo disengage option is not activated. So you'll notice the activate button. It's like, again, reverse logic. It's not a tick box. It's basically, at the moment, it's not activated. If you want to activate it, you have to select deactivate. So now it's actually activated. So this servo disengage function is now on, and now it's off. So when we have it off, if I try and push against the servo horn, I can't push it. I'm pushing against the actual motor. The motor's powered up, and it's pushing against me. If you listen really carefully, you might even hear the motor sort of buzzing a little bit. It's not very loud. Anyway, if I deactivate this, or select deactivate, I selected activate. Now I'm getting confused. So now it's active. So this function is now active. The servo disengage function is now active. If I push the horn now, I can freely move this horn. You say, okay, what's the big deal? Where would you use that? Well, in a second, I'll explain. So, another thing to remember these servos, Hall effect sensors? There's no potentiometer. Watch what happens. Bet you can't do this with most servos. That's a full 360-degree turn, and I can keep going all day long. All right. There is no stop. There's no physical stop with these servos. Again, remember from my first video, I explained why. So there's the magnet on the end of the shaft, goes over a little magnetic Hall effect sensor. So there's no physical stop. So this servo doesn't really care where the arm's positioned. So always keep that in mind when you're programming these servos, because it can open up some endless opportunities if you're not using them in a sort of a standard configuration. And I'll show you in another video later on in some more programming options, maybe when I've hooked it up to the transmitter, how we can use them like as a winch servo, for instance. Now, let's say we're setting up an aircraft for whatever reason, and the servo horn has to be here, all right, for whatever reason. So one option was, like I showed you earlier, was to click through here and click the amount of degrees, get it nice and set up perfectly, save it, done. Well, here's another option for you to ponder. If we activate this servo disengage function, we can now move the flight surface, whether it's, whatever it is, you can move it manually because the servo now is not stopping you from moving it. It's just freewheeling basically. So you can move it and we can position it exactly where we want. Say, make it about here. That's exactly where I want the neutral to be. Now all you need to do is then click on this Learn Neutral Position, go Activate, and you'll notice it's automatically put in an offset of 70.2 degrees. And that's because, remember the Hall effect sensor, as we rotate this manually, the Hall sensor is still operating fine. It's still sensing exactly where the servo horn is positioned in a 360-degree sort of operation. And it knows it's, the new neutral position is here. And if I save that, it's saved. Now, watch what happens if I back out of this. So back out. Let's move the horn here. So remember the neutral used to be here, but now we've saved that 70-degree position. Let's see what happens. Unfortunately, it's not connected to a transmitter, so I can't control the servo via the TX, but if I go into here now, building menu, and read the neutral position, it will say 70.2 degrees. Now at the moment, I still have this servo disengage option activated, so there's no drive to the motor, right? It's freewheel. Let's activate it. Now what will happen is the servo will move to this new neutral position. There you go. So that's the new neutral position. So remember we set this manually. So in some cases, you might find it's actually easier to set it manually on the flight surface, save it, done. That's your new neutral position. When you're setting up the aircraft, that could be a handy feature. I've already got a few applications where I could see myself using this feature. So that's pretty cool. I like that. Okay, that pretty much explains most of the options here. And I'll delve into these all these options again when we cover it off in the transmitter and also in the PowerBox, the new PowerBox iServo terminal program. It'll be better when we're using the transmitter because then I can operate the servo. Because at the moment we can really just set neutral, can't really control the servo from here. Maybe that's an option for future use, make it into like a servo tester. Have a servo tester option, that might be handy. There is another page here. So this page here, there's a performance type. There's a couple of different settings here. So we've got, if I scroll all the way through, we've got standard, performance, accurate, needs another C there, Richard, ACCURATE, torque, competition. So there's a couple of options there. I'll delve into these when we cover off the actual PowerBox iServo terminal program because it has a little graph in there and I can sort of explain it a bit better. So basically these really change the torque curve and also the deadband. They affect the deadband a little bit as well by having these settings altered. So you have like a standard setting, performance, accurate. The default is accurate. So that provides like a tighter deadband. And then you have a torque setting, a competition setting. But like I said, I'll explain those a little bit later in another video. You have the factory reset 3x button. So remember with the new iGyro software, we've got this new technique now where you have to hit the button 3 times before you do a reset, whether it's on the gyro or this servo here. So if you want to reset all the settings, you've got to hit it 3 times. So on the 3rd time, servo's now reset. So it's reset the neutral position. It's gone back to its normal default. And the last option is just the display of the P2 bus address. A spelling error there as well. That could be on purpose because I can't fit enough characters. That's about it, I think. So that'll be enough for this video. Didn't want it to be too long. Like I said, we'll go over these again in the next video. So I might do the transmitter next. So I'll hook this up to a receiver using the P2 bus, and we'll access all these same menus through the transmitter. But it might be a little bit better because I'll be able to jump out of the menu, control the servo, show you basically what effect some of these settings have. And then the 3rd video in this series of programming, I'll cover off the new iServo terminal program. So you need the USB interface, a PC obviously. You run the software. There's a lot more options, or there's a number of extra options in that software that are not available from the mobile terminal. And, you know, like one of them is a soft start. You can actually change the time or the delay in the soft start, for instance. So from here, you just turn it on and off. But from the actual iServo terminal program, you can actually adjust the time. So you can make the servo really slow or fast or whatever you like. Okay then, like I said, just a quick video. Next video is going to be probably a lot better with the transmitter. And I'll probably knock that up in the next few days or maybe next weekend. I'll catch you all then on part 3. Thanks all.